So now that we reached the second part of the video, I'm going to be talking about how to translate functions, especially cubic and quartic functions. Right now I'm just sketching really quickly the function of x to the power of 3. With that, I just drew a little table below with x values, and then I substituted them to find y, and just plotted the points and sketched a graph. So now I have to do a translation of the function f of x plus 2 outside the brackets, which basically means that you're going to have to move all the points of the function upwards twice, so 2 points above of the points. Now I'm going to draw the same cubic function again, however I'm going to have a translation that drags all of the points downwards. So the function will be f of x minus 3 outside of the brackets, which means there will be a vertical translation downwards. So I'll have to plot the same plots again, however 3 points below than their original point. Now very quickly I'm going to be sketching a quartic function just so that we know how it looks like when there's a translation with a quartic function. Basically it's just the same thing. We plot all of the points downwards or upwards depending on the number that comes after the brackets of the f of x. So in the first example in red, we can see that the function is f of x plus 1 outside the brackets, and I'm drawing f of x minus 3 outside of the brackets. So we can see how the function that goes upwards is the positive one, and the function that goes downwards is the negative one. The reason why I'm specifying clearly the placement of the number, if it's outside the brackets or inside the brackets, is because that number alters the transformation of the function. Here I'm quickly writing something that you might want to write as well. Basically it's when there is an addition to the function outside the brackets or subtraction to the function outside the brackets, the function will either translate upwards or downwards. So now I'm just going to write this down on the corner so that in the end we have a quick summary of the translations and the stretches. So here I'm just writing quickly the overall formula of what happens in a vertical translation. So now we're going to talk a little bit about horizontal translation. These translations happen inside of the brackets. So when you have a negative number inside the brackets, then the points of the function will be dragged to the right. And if there's a number that is a positive number after x, then the whole function will be dragged to the left. Now I'm just quickly drawing a sketch of a quartic function and how I would translate it with the function of f of x minus 1 inside of the brackets. This would mean I'd have to drag all the points of that equation, right, of that graph, once to the right. And after all, minus 1 is a negative number, so I'd have to drag it to the right. Now, f of x plus 3, this would mean I'd have to drag my original function 3 times to the left. Now I'm just quickly going to write down another quick summary on horizontal translation, which would also be useful for you to write down and have. So when there is an addition or subtraction inside the brackets of f of x, the function translates to the left or to the right. Now let's go back to our famous corner and write down a quick summary of what we just learned of horizontal translation. So f of x plus a means it's going to go to the left, and f of x minus b means it's going to go to the right. Now that we've finished looking at translation, let's look at stretches. To begin, we're going to look at vertical stretches, and they have the scale factor of p. So if you were to find a function, it will probably be pf outside of the brackets and then x inside the brackets. So here's a sketch of the function x to the power of 3 minus 2x to the power of 2. If I were to find the sketch of this function 2f of x, my scale factor would be 2, and I would have to multiply the whole function of x to the power of 3 minus 2x to the power of 2 times 2. So since the 2 is before the f, I know that it will be a vertical sketch. We can see how my curves became deeper by double the initial amount it was before. And we have to always remember that stretches are always stretching from the x-axis and not from a particular point. So now let's go back to the corner again and write down a quick summary of what we just learned. So pf of x stretches the function vertically. So that's how we know what the number before the f actually means. Now let's talk about horizontal stretches. Horizontal stretches have a scale factor of 1 over q, which also can be seen as f, and in the brackets q, x. So now I'm just drawing a simple graph of the function y equals x to the power of 3. The function is red is the function f of 2x inside the brackets. Notice how my function still passes through the origin. However, the function was compressed in a sense and became half of the size it was. It is important to notice that when stretching, the function will always pass through the same points when y equals 0, so it will always pass through the same points in the x-axis. That's because the stretches occur from the exode of the x-axis and not from another point. So now that we finally finished all of my topic, I'm just going to write a quick summary of what we just learned. So f of qx stretches the function horizontally. And that is basically everything that we had to learn. And I'm just going to draw a little cloud around the summary of this stretching and translating topic. So that's basically it. So now we can cross out my list.